will be stacked together, become sluggish. It looks like a cold weather. You're sluggish by yourself, you're shaking, that's sluggish. Once the sluggish happens, what happens? You will have a nuclear center. So the nuclear center happens if the freezing temperature is very minimized, which means -5, -10 degrees Celsius. They will generate large ice crystal. Then the large ice crystal will damage the tissue. So that's the reason you buy a beef, put in your home refrigerator freezer for 3 months, and you cook it. You don't like it. The tissue is completely softening because of crystal. So what's the industry they do? They do flashing freezing. They do it really quickly, or use high nitrogen, like -196 degrees Celsius. Looks like a boring, surrounded the beef products. So just want to let you know, beef, pork may be okay. Seafoods is more severe. You buy a bag of shrimp. If you put it at -10 degrees Celsius for 2 months, then you took it out, you don't like it, because the tissue is completely gone. Just want to let you know, this relates to the crystal, ice crystal. I don't want to get to here too much, because that's another topic, is food and chemistry, okay? Usually the home refrigerator temperature is 5 degrees Celsius, but that's not good. We talk about dangerous temperature zone, 50, 150 degrees Fahrenheit, 40 to 140 degrees Fahrenheit. But they do the survey, most of the refrigerator temperature in the United States is 5. That's not good. Listeria monocytogenes will grow. Pseudomonas will grow. What are human body temperature? 37, you know that? Okay, 63 is, we say it's a lower temperature pasteurization. 72, flash pasteurization. I don't know whether you notice about it. You may never notice about it. If you buy a bottle of milk, if you tomorrow buy a bottle of milk, you look at the label, they will say flash pasteurization. What this means? They are going through only 15 seconds at 71.6 degrees Celsius. What this means? Background bacteria can be killed, but not in those spores. Okay, if we want to do spore, what we have to do? More higher temperature, 2 hours in the boiling water. Maybe not enough, so we have to do autoclave. 15 minutes autoclave. That's the temperature goes at 121 degrees Celsius. Well, 140, 160 degrees Celsius, that's cure. It's huge. Everything is going to be gone. Okay, so just want to let you know. Now, of course, we have a dry heat and a moist heat. It's just a dry oven, moist oven. Use the moisture is more effective compared to dry heat, but not necessary all the time. Pasteurization, generated by Louis Pasteur. That's why I call it pasteurization. Your milk is pasteurization. So milk in a bottle, you could be stay about a week. Longer than that, the sporage bacteria are going to grow. You tasted a bottle of the milk, 10 days later, it's tasted like acid, because sporage bacteria start to grow. You cannot heat the milk too long. If it's too long, what will happen? Lysine will be gone, cross-linking of the protein. That's for the chemistry, so we don't want to talk too much. This is a typical autoclave in the lab. If you go down the hallway about 10 meters, 10 yards, you will see a room, have an autoclave. This is autoclave. And they have a pressure, usually is 121 degrees Celsius, 15 minutes with 15 psi. They can kill everything. I mean, if the autoclave is functional. Now, how do we know the autoclave is going to be working very well? We put an indication microorganism. It's called geobacillus, because geobacillus is thermophiles. They can survive at 100 degrees Celsius, but will be killed at 121 degrees Celsius. So geobacillus we're using as a quality control. Radiation. So we can use radiation to kill bacteria. A very simple example, when you grown up, you definitely heard about your parents or your teachers will tell you, go ahead to have some sunshine. Now one reason is to let vitamin D to be created in your body. So they said that in West Virginia area, during the fall and winter, let's say from October to March, you should daily take vitamin D because we don't have much sunshine. But in the summertime, you should at least have 30 minutes to 1 hour sunshine because that's for vitamin D. But have the sunshine also will killing the bacteria on the surface if it's a harmful bacteria because of radiation. And the radiation will cause what? Cytodema. They will block the DNA replication for bacteria. But you know it's only temporary. They can be fixed later. Okay, so the radiation. We do have some radiation products. There is a safety concern about that. People also worried about the residue radiation on the surface, but we do that all the time. And I tell you one thing, there is a product actually using radiation, you doesn't realize it, is ground beef. Because ground beef is zero tolerance. So when you go to the markets before the packages, they all going through radiation. Make sure the final surface, there's no bacteria. Lots of the plants, they do like that. Okay, general principles of chemical control. This gives you a topic. What is the ideal antimicrobial chemical? First of all, they have to kill bacteria. Second, the non-toxication for human and animals. Third, we want them to be easily to be prepared. Is that right? So we have to be dissolved in the water. There are some of the ingredients only dissolved in the alcohol. We don't want that. So in order to be dissolved in the water, we most of the time make them as a salts. So we call it a salt ingredients or salt compounds. They need to have a longer storage time, so storable. Well, quickly effective. We want them only 30 seconds can kill everything. Although it's not going to happen. And we want them to have a lower concentration as little as possible. But I want to tell you one thing, they are non-existing. Antimicrobials can fit all these 5 categories, 5 dots. Because there is a certain temperature, pH, and duration have the restriction for that. Okay? We want to talk about the cleaning. So what's a cleaning for? Basically, is remove food soil. What is the food soil? It's residue fat, protein, carbohydrates, mineral salts on the food contact surfaces. So using soap, you're actually doing the cleaning. So what's a cleaning? A name of the chemical to do cleaning, we call it detergents. The components is surfactants. So let's say polypropylene glycol is a surfactants. Because we want them to do emulsification, they can break down a large molecule become small molecule. And those type of components, we rely on a builder. And the builder could be alkaline acid, enzyme, or oxidized agents. Now we also want to put a filler there, make sure they can be water soluble or safe to use. Sometimes we add something to inhibit the corrosive because we certainly don't want them to hit a human being. For example, touch your skin, we want to be safe. For the cleaning, basically is physical interaction of the food soil. Change the solubility and the chemical interaction with food soil to form water-soluble substances. That's some more examples for the cleaning. Ammonia compounds is a cleaning, but at the same time is also antimicrobials. A couple of years ago, I did the research for centropyridine chloride. This one is very effective to killing salmonella on poultry carcasses. And you add it there because it's like a soap. It's very, very, very effective. Okay, regulation. This might be changed. Serious. Then we may not have EPA anymore. Okay, but the current regulation for sanitizing to be used first need approved by the EPA, Environmental Protection Agency. They need to see the antimicrobial efficacy data, chemistry, toxicology data, and the labeling. Then they need approved by FDA, which is Food and Drug Administration, and the USDA FSIS, Food Safety Inspection Service. They need to make sure the labeling is correct and the use of food contact surfaces is safe. This is very old, but we still use it. FDA approved about 30 years ago, in 1996. These are the antimicrobials treated as a sanitizer on food contact surfaces. So there is a chlorine-based sanitizer. Chlorine, we will talk detail later on. Chlorine. Chlorine also have a gas formation. We call it chlorine dioxide. Okay, iodophones. Iodine, basically. Okay, using iodine, there is a good advantage. You know you added it because it's brownish color. Especially when you do the quality control, you do the recording and keeping documentation, you know you added it. Commonly used in the lab is contrary ammonium compounds. And we also could have an acid sanitizer, the carboxy acid sanitizers, but be careful for those. What will happen? Those is very toxic, those very corrosive, because acid could be corrosive for your skin surfaces and a very low pH. Perioxyacidic compounds, this is widely used. There is a product called Sanidate 5.0 called combined hydrogen peroxide with perioxyacidic acid. And very important, this product is approved to be used during organic foods processing. Others probably not. Okay? Okay, some other things. Little bit briefly. Phenolics. Okay, phenol group. This is a very old, it's a first generation antimicrobials. Can be used laboratory or the hospital. The problem will cause very severe skin irritation. So, phenolics, probably not too much these days. Alcohol. I don't want to go these details, but I have only one thing I want to tell you. Pure alcohol will not kill bacteria. And I can tell you one thing, 15 years ago, I inoculated bacteria in pure alcohol under microscope. They are moving very well. Alcohol must dissolve in the water. Only diluted alcohol will be effective to kill bacteria. Basically 75% or 95%. 100% alcohol not going to kill bacteria. Keep in mind. And also, that's not effective for virus. It's very interesting, during coronavirus, everybody used 95% alcohol. May not be working very well. Contrary ammonium compounds. This is the one we widely use in the lab, but be careful. They are not effective for endospore. And this guy, Mycobacterial tuberculosis. This is the #1 compounds used in the lab to clean the surface. In our teaching lab, we have that one bottled, but not effective for Mycobacterial tuberculosis. But it does not matter for us because we are biosafety level 1 lab. And this is biosafety level 4, and endospore bacteria biosafety level 3. So just want to let you know. Aldehyde. Formaldehyde, what they do? This is in the museum when we do the storage of the tissue, the animal tissue. It's used as chemical steroids for animal tissue only. Okay. These days, we generate lots of the biological control microorganisms. some of them coming from the bacteriophage. It's a virus, which means they will be cause the lysis of the bacterial cell. We can also using bacteria cell. Another one we're using a lot is the lactic acid bacteria. We call it a beneficial bacteria, but actually it can kill lots of the other bacteria. So this is end up with what we talk about here, relate to the microbial control. Okay, so basically we finish here is the exam 2, the lecture material. But I always remind you, do not forget, start to read after class reading 1, 2, 3. These will be the material you use for answer the exam questions. But instead of you reading in the classroom, at least you read a little bit during the weekend, okay, or next week. For the exam 2, I will put one sheet of the practice exam there, then you can, I'll also put the answers in, then you can study by yourself. Again, it will be open book, but we'll have some case studies. Okay, so these 3 after class reading material, don't forget about to read it.